Hello, my name's Max. I am an application developer. I work in PHP. I also work in Python. And on bad days, I have to work in Node.js. This is a photo of me. A colleague of mine pointed out I'm the only person on the conference website who isn't smiling. So thank you, Frank, for sticking the boot in before we've got going. I work for a company called Vice Media. We're a global youth media company. But there's something interesting about what I do and what my team, my colleagues do, is that we work on internal line of business programs. So I don't work on websites. I work on, at the moment, business intelligence, which means that I deal with lots of data, and I use that data to answer questions about the business and to drive process improvements for the business. So there's some assumptions that I make that come from the sort of work I do and the sort of company I work for. So I'm from what you might call a sort of enterprisey background, which means that I have access to operations support. I have DevOps people. It means that I can try new technologies quite quickly because I'm in a position where I'm not beholden to some external client on a fixed cost contract. Also, working on internal things, I don't need to worry about scaling things. Most of our projects have fewer than 500 users. So concurrency and cache stampede and lots of, you're going to the top page of Reddit doesn't really matter to me, which is slightly weird given a lot of this talk is about performance, but that's something to bear in mind. And really importantly, the talk is supposedly about databases, but I'm not a DBA. So I do apologize if I get things horrifically wrong about relational databases. I wouldn't consider myself an expert in them. And there's one last thing about working in a big corporation that I want to mention, which is Remy's law. And Remy's law states that no matter what the actual requirements, what your users really want is for you to implement Excel. Working in a big corporation does often feel like you're either reinventing Excel, or even worse, you're just a machine whose only purpose is to feed data into Excel. And this does actually relate to the topic of the talk. It relates to denormalization, and you should keep in mind how that might be as we go through it. So we're going to talk about denormalization, but before we can do that, we really need to understand what normalization is. And I wanted to work out how many of you are likely to know what normalization is. Now, I could ask you to raise your hands, but that's only going to cover people in the room. I wanted to be much more scientific. So I went for the authoritative source on how popular any topic is, which is, of course, Google Trends. So this is a line here from 2004 to the present day for interest in normalization. It's been getting less and less popular. And that's probably because everyone's already denormalizing their databases, and you don't even need to listen to what I'm about to say. Or not. Denormalization seems like no one's really talking about it. So I wondered what we could proxy for denormalization. Because denormalization is just one way of structuring a database, and we need to remember that there's lots of ways of doing that, and some of them don't involve relational databases at all. So let's look at normalization versus MongoDB. Seems like a lot of people are interested in MongoDB. Maybe we should be doing that if we want to be rich and successful developers. Just make sure that you don't do this. So both of these figures are sort of useless if we don't know what our control group is. What's a popular thing that we can compare it to? So what I've done here is put the trend line for Kim Kardashian versus normalization and MongoDB. You should probably just walk out of the room now. If you've been doing anything since 2007 except trying to become Kim Kardashian, you've probably not been doing the right thing. So what is normalization? Essentially, normalization is the process of organizing the columns and tables of a relational database to reduce data redundancy and improve data integrity. So it means we avoid repeating our data, And we also avoid any need for unnecessary writes. And we need to think a lot about rights when we talk about normalization, because a lot of the aims of normalization are around rights. So this is Edgar Codd's aims of database normalization here. So it's mainly the first one that's really important, to free the collection of relations from undesirable insertion, update, and deletion dependencies. And that means if we're not repeating data, when we want to change it, we only have to update one row at a time. We don't have to update multiple rows. And I think that really sort of sums up the core aims. I'm also going to draw attention to his third aim here, which is to make the relational model more informative to users. That's a slightly interesting one, because I don't consider the users of my applications to be users of my database. So we have to remember when thinking about this sort of thing, that this theory comes from the early 1970s, and it comes from a place where you're likely to have your users literally writing queries against your database. So that's something to consider, the historical context of normalization. It's a quite deep topic. You can see I've done some detailed reading on a good 4 of these subjects, by the links being a darker blue. Essentially, we go from the unnormalized form, which is a sort of naive database, through the second, third, fourth, fifth, sixth normal forms, until we get better and better, and at the end, we reach denormalization. So I think this is a great table, says where we should be going. Unfortunately, after denormalization, we do have to do some refactoring. We don't really need to worry about most of the things on this list. The most important thing, and what you're probably used to, is the third normal form, which is every field must provide information about the key and only the key. That's the third normal form summed up. This was a theory published in 1971. And you're probably doing something like this, or going most of the way with this with what you do today, or at least you hopefully are. So we're just going to go for a little brief example. So we have our Kardashians here. This is the unnormalized Kardashian table. And what we have here is information about 4 of the Kardashians and their addresses. But what we can see here is that the address column repeats. So Kim Kardashian and Khloe Kardashian live at the same place, and we're repeating that information. And Kourtney Kardashian and Kylie Jenner also live at the same place, and we repeat that information too. So that's our problem. That's making us unnormalized. So to normalize this table, we just pull out an addresses table. So we have a foreign key reference in our address column here. The reference is an address. So now if we ever want to update the address, we just have to change it in one place. We don't have to change 2 rows of our unnormalized table. In this case, you could say this only works as long as Kim and Khloe live together forever. But generally, this should give us a better situation than the unnormalized form. And we can keep going with this. So what we see is that normalization increases the number of tables. So my business case here is I need to track the Kardashians, and I need to track their favorite things that begin with P. So I've gone for Power Rangers, Pokemon, and PHP frameworks. So a minute ago I had 1 table, now I have 5 tables, but this still isn't fully normalized. Because an address usually has an associated city or county. It usually has a country. So that's more repeating information that we need to pull out into its own tables. And we have to apply the same thinking to our Power Rangers and to our Pokemon. So a Power Ranger has a color, and a Pokemon has a type, and a Pokemon has a generation, a game that it first appeared in. So we've immediately gone, very quickly, from 1 table to 10 tables. That's going to start causing some problems for us. Let's talk about what we do when we read from these tables. And this is what denormalization is really all about, is about reads. So normalization is all about writes. Denormalization, all about reads. When we're doing this read, we're joining all these tables together. So let's go through very quickly what that looks like for our example. When we had an unnormalized table, we just had to select from one place. When we did a little bit of normalization, we had to select from 4 places. Now we've got some left joins creeping in here. And you might be using Eloquent to do all of your database work, in which case this is somewhat hidden from you. But it's important to understand that Eloquent is going to be issuing queries that look something like this to your database. As we fully normalize our tables, we suddenly have this whole stack of joins. We're starting to see maybe some performance problems. Maybe not in this example, but in the real world, you're going to encounter things that involve 20, 30 joins. If you have 20, 30 left joins, it might not be a great thing to be hammering your database to do that work every single time someone arrives at your website. Let's think conceptually what these queries look like. We're taking our 10 tables, and we're starting to squash them down. We're starting to combine cities and countries, power ranges and colors. And we're going all the way back to one table. So we're projecting the 10 tables that we had a minute ago back into what we can effectively think of as one table, which is our read result. Whenever you're on your application and you're trying to create a listing table, I work in the sort of corporate world. People love listing tables. They want to see every piece of information they have at a glance so they can sort through it. Unfortunately, they also want to download it into Excel, which by its nature is a flat table. I've projected it all down into a flat table for them to look at it, but I've paid a cost to do that, which is I had to do all of those joins to go from my 10 or 20 or 30 tables back down to one place. And we see real business cases like this all the time. Almost anything you do is probably going to involve some joins. Any export you do is going to involve joining information, flattening it, and giving it out as a CSV. It's something that can sometimes be avoided, but if you're like me and you're working inside a business, if you work in the software iceberg, then you probably do this a lot of the time. And many joins are bad for performance. Left joins are especially bad for performance. And then if we ever tried to add some filtering, some sorting to this query, especially if we need to do that over left-joined elements, it's going to get even worse. We might even need a subquery in there somewhere. We might need to do some complex business logic. And at the point we're joining to that subquery, to that subselect, we're going to start hitting really bad slowdown. There are queries I've seen in my day-to-day job that take 4 or 5 minutes to run. And that's when we have a system that has 10 people using it at once. If you're developing an application that has 10,000 people doing that at once, you need to ask yourself, why am I paying all of this cost in terms of performance, in terms of database work, to do these reads? So what's the solution? Denormalization. It's actually a solution to the performance problem, and it's also a solution to some complexity problems we might face. So, like I said, I'm not a DBA. In fact, I don't even particularly like writing SQL. And sometimes you might have huge amounts of logic in your SQL that you're having to repeat over and over again. You're perhaps doing a little bit of passing a prepared query builder around. Perhaps you're doing something more naive than that and just doing sort of string replacements to get your business logic in terms of SQL. But at some point, it's likely that even if you are using Eloquent, you're going to have to drop down to this sort of very complex logic to serve certain reports or certain tables. So we need to think about how can we make that read have already happened. That's what denormalization essentially is. We've already done the read before our user arrives, and we have the result ready for them to go. And the big problem there that we're going to see how to solve is how can we then, if we're sort of pre-reading, if you like, how can we make those results consistent with our source of truth, which is our normalized store? So we can sort of think about these queries as a projection into one table, and there's a way of doing that in your database. It's called a view. So a view is essentially a query that behaves like a table. So you say to your database, give me this view, and every time you query against it using it like a table, it's running a query for you and giving you the results. Doesn't really solve the performance problems, but does start to sort of hide away some of the complexity and give us a slightly different way of thinking about things. So this is how we'd make a view in Laravel. This is a Laravel migration. We just have the up method here. So we're just saying create view Kardashians as our query from before. I've just done select star here for reasons of space, and you should be careful with stuff like that. In MySQL, a view is frozen when you create it, so you're not really doing select star. You're doing select all the columns that exist at the time I make the view. So I would say generally select star could be considered harmful. You certainly don't want to do it here. Once we have this view, we can even hook it up to an Eloquent model. So here we have our denormalized Kardashian Eloquent model. All we have to do there is say that it should be backed by the view. Works in much the same way as a table. Just don't try to write to it because your database won't like it. So that's sort of conceptually what we're trying to do. But like I said, it doesn't solve our performance problems. So we need to go one step further. We need to go to the materialized view. A materialized view is like a view, but it's not a view. It's just a regular table. Has all of the columns from our view with the same types, the same lengths. But because it's now a table, we have to fill it ourselves, which is some work that we're going to have to do ourselves as developers. We're going to have to make our application do it. That's sort of the downside. The upside is that we can take all of the work of these reads away from the user. We can do these reads before the user has ever arrived at our website or our application. We can even put indexes over the result of the reads. We're just using a regular table. So we can make all of our filtering, sorting much quicker. We get rid of all of the joins. There's also some other stuff that this is going to give us that we'll talk about in a minute. But first of all, let's talk about how do you achieve a materialized view? You have to get the data into the table. So you've got three options. First one is you can fill the table once and only once. You can run a one-off command to fill your table that's backing your materialized view. Might not happen very much in your real use cases, but sometimes you do have cases where you have very slowly changing data. Perhaps your data only changes once every 6 months. If it only changes once every 6 months, just fill it once. Write a command to do it, run your artisan command. When it changes again in 6 months, go through a change process where you manually fill the table again. More likely, you're going to want to run a query to fill your table at intervals. So we can pick an interval. So we can say 24 hours. The table updates every 24 hours. I do a fair bit of data warehousing work. And this is sort of a very traditional data warehousing approach. You have a write window overnight where the system closes. No one's allowed to read from it, and it runs all of its batch jobs. It updates its materialized views, it sucks in new data, and it does that once a day. If your query to fill the table can be made a little bit faster, do it every 4 hours, do it every hour. If you have a very small database and you can do this entire process in 10 microseconds, run the query every minute. It's really simple to set up something where it just says, do this on this schedule, and that's going to maintain my materialized view. One of the ways you can speed this up is use your created at, updated at timestamps from your Eloquent models when you're running this update to only look at what's changed, to only look at what really needs to be updated into a materialized view. And again, that's going to help you get the performance better so that you can run this more often. There is one downside to this, is that it's not immediately consistent with your normalized source data. So you're working in an eventually consistent fashion. Your users might have to wait 24 hours for their reports to update after they perform a read. If you ever ask your users that, they're going to say that's a huge problem. In practice, it's how a lot of the world works all of the time. So don't be afraid of eventual consistency. A huge amount of your life is eventually consistent. If you pay for something with a credit card at a shop, the money is not immediately deducted from your bank account. You might have to wait a few minutes or a few days for that to show up. And the same thing applies to the sort of systems that you're building, that we're building. Generally, people can wait before their data shows up in big reports that they're used to downloading. But we don't have to run on a schedule. We can actually just update the materialized view as the source data changes. And we can do that using Eloquent. So if you're already using Eloquent to manage most of what goes in and out of your database, to manage most of your application, you can get Eloquent to tell you when writes are happening, and you can use that to update materialized views for one model and one model only, as and when it changes. So it looks a little bit like this. So we have a model. The model raises an event to say that it's been saved. We listen to that event. We build our materialized view off the back of that event, and we save our materialized view to the database. As this is written, this diagram right here, we can even have transactional consistency for this, because we can wrap the model writing to the database and the materialized view writing to the database in the same transaction. And we've achieved immediate consistency, which for some people is a big bonus. Personally, I think that an eventually consistent model is preferable, because what we can do is take the event into a work queue, take it away from the user performing the write, maintain really good write performance that normalization gives us, and just do the work for the materialized view later on. So I'm just going to go through how we can do that in Laravel. So here's our person model again. It's really simple to get this thing to fire an event when it's saved. It's right there. We just say, here's the events. When this model's been saved, raise a person saved event. You have a few events available here for sort of model life cycles in Eloquent. You have creating, created, updating, updated. We're using saved here. That means two things. It means one, this fires for every single write that happens. So it fires if it's a new model getting written to the database, and it also fires if we're updating an existing model. And two, it's the past tense saved event. So it happens after the write has happened. The database has already accepted the write. We can be fairly confident that write has happened to our source data. So of course we name the event as well in the past tense, the person saved event. And this is what that looks like. Again, it's really, really simple. This is basically just a very small data transfer object. And it's got a little bit of Laravel decoration to make it go through the queue nicely. So it's a queued event, and it uses this serializes models trait to make sure that the model survives going into the queue properly. But apart from that, it's really just passing the person around. Now what we have to do is hook this event to a listener in the sort of normal Laravel way, and hook it up to some logic that looks like this. I mean, this is basically just pseudocode, but this is our denormalizer. It takes a person in, it finds the denormalized representation of that person. If it doesn't exist, it makes a new one, and then it fills in. And it's calling all of these relations here. This is where our joins come in from before. So we can see we're filling out the favorite Pokemon. We're looking into that other model and getting an attribute from it. We're filling out the favorite PHP framework. We're looking into another model, and we're getting a name from it. This is where our joins happen. And we saw earlier that all of these joins really slow down reads. But the beauty of this is we're now in a work queue. It doesn't really matter how slow it is as long as it's not ridiculously slow. And this sort of stuff isn't happening every single time someone visits your website. Your number of reads is very likely to be larger than your number of writes by orders of magnitude. So let's just do this reading work one time when we do the write, and then we never have to do it again. If this person is never updated again, we never have to do this logic again. If we're constantly trying to read from the normalized database, we have to do this work every single time someone loads that page. And again, we can use this materialized view really easily with Eloquent, because it literally is a table. So we can hook an Eloquent model to it the same we would to literally any other table. So here we've just said that the table is MW underscore Kardashians. So MW is a convention that we use to reflect a materialized view. So it's important to flag in your databases what these things are. We tend to name views as VW underscore, materialized views as MW underscore. And that lets someone looking at your database know what this means to the application. You want to make sure that people sort of new to your project have some understanding of what's going on at a glance. So if you're going to do this, I have some pro tips for you. Number one is monitor your queue. It's really good advice anyway, if you have a queue at all. We're aiming for eventual consistency. If your queue worker dies and you don't know about it, and the number of jobs in that queue stacks up and up and up until there's 100,000 jobs in your queue, I'd say you're no longer eventually consistent. You're probably very eventually consistent, and that's when you start to get angry users. The second thing is heavily related to this, is have an artisan command ready to rebuild all of your materialized views from scratch. Because sometimes things go wrong. Sometimes you want to change the design of a materialized view, and you need to refill it from your normalized database, because your normalized database still remains the source of truth. If you don't have this ready to go, then it's really going to slow you down when you need to make that change. Or your queue has crashed, everything is broken, and you need to rebuild immediately. So you need that deployed at the same time you first deploy your materialized view. Some of you here probably have databases that are way too big to rebuild all of your materialized views at once. And if that's the case, I'm afraid you're on your own, and I can't help you. And the third thing I would say, we name our materialized views in the database to make it obvious what they are in the database, but we need to do that in the application as well. So we should probably do something like this with our model. So this is programming defensively. So here you're defending yourself. You're defending yourself against your intern or your work experience person or just someone who's new to the project. Your application code should represent what is possible to do with this model. So it's a materialized view. I shouldn't really be writing to it apart from in a very specific way. So I've turned off the ability to save or create. I'd love to do that by making them private, but I can't because of how PHP works. I've just said, you're not calling this, I'll refuse. And I've offered one public method here, which is fill from person. So this is just our logic that was in our Kardashian denormalizer earlier, but I've moved it into here. And it says that all I can really do with a materialized view is take the source data and update myself. When I say fill here, this is going to do all of the filling itself, the actual fill method, but it also retrieves the materialized view model if it exists, and it also performs a database write. That's the only thing you're allowed to do with materialized view. What you're allowed to do is give it a person and update it, and we should definitely reflect that here. So that's sort of how we can do denormalization. That's how we can improve our read performance. I would strongly suggest having a go at this if there's that sort of one query, one report, one table in your application that is slowing everything down, that's really complicated, that takes 40 joins, that has a load of logic in SQL. This is probably a good way of getting some performance gains when you encounter that sort of problem. But it's not just performance gains. There's sort of some fun things we can do with this as well. Because what we've done is given ourselves the opportunity to hook into the process of things getting written to the database, to find out when that happens, and to respond to it. So we can use this here to populate a search engine. You might be using Scout to automatically get yourself into your search engine. But perhaps you don't want your search engine's data to look the same. It's really just another projection of your data. It's a potentially very unique structure for your data that you're using for searching. So we can do that here. We can restructure our data and send it off. We could run it through something like Fractal, which allows us to transform our data into different shapes, give things different labels that we can keep consistent, all of these great things. It's not just applicable to search engines. Maybe you need to call an API somewhere else in your sort of set of applications to tell it that a write has happened. So hook into that there. And again, it's likely we're doing some projection there. And that may well be projection that looks an awful lot like denormalization. If your API is Node.js and it's backed with MongoDB, it probably wants you to send it a document rather than some information about 10 different models. So do that here. That's denormalization. Rearrange your normalized database into a document. There's another great thing we can do, is that once we're doing this logic in memory, we can do in-memory business logic. Some of the cases that we've had very poor read performance is in our systems that handle monthly financial reporting. That involves lots of date handling. It involves sort of trying to implement window functions somehow into MySQL. We ended up with a hybrid approach where we sort of pulled raw data down from the database, worked it in memory to sort of look at all these buckets of dates and all of this, this logic, and then presented it to the user. It's extremely slow. But if you have a denormalization process, you've already taken the work away from the user, and you also don't have to look at your 10,000 row report. You only have to look at one row when that gets written. So as the write happens, it's really simple. You just do your date handling, you look things up from other APIs, you maybe make some additional queries to check some other things, put the results all together, put it in a materialized view. When someone wants to download your report, all your application has to do is do a really simple database read from one table, which databases are generally pretty good at doing. The other advantage here is if we're doing in-memory business logic, we can run in-memory tests. So if we're always relying on our database read, and I'm talking here about the sort of read where you have dropped down to the SQL level. You're no longer using Eloquent. You're writing SQL yourself. You're trying to do some business logic, work some maths out in your query. If you're doing something like handling lots of money, you probably need tests on it. So what does testing look like for this sort of way of doing things? Well, first of all, when we start the test, we have to boot Laravel. If you're running integration tests with PHP unit under Laravel, you're booting Laravel every single time you run a test. That has an overhead. You have to set up a database. You have to create tables. You have to seed them. That's an overhead. You have to insert your test data. You have to have some fixtures, some known data that can go into the database so you can then run a query and check the results. This process It's quite slow to write. There's quite a lot of work involved for me to write these tests. I have to make sure the database is in the correct state before I run the tests. Can go wrong quite easily. And it's also quite slow to run these tests. They're quite memory intensive. If you have a large Laravel integration test suite, you've probably seen the memory of it grows and grows and grows. The memory consumption, especially some versions of PHP unit that hold on to things for slightly longer than they should, perhaps. If we move all of this business logic into running it in memory, in PHP, we can then do unit tests. And unit tests, much easier to write, much faster to run. So this isn't to say that integration tests don't have a place. I think it's really important to have integration tests and unit tests for different things. But certainly, if I'm trying to write some logic and test some logic that is going to deal with money, that has to do some calculation, that has to come up with the correct result, I'd much prefer to be able to unit test it. It's a two-step process. I feed test data to my calculator class, and I check the results that it gives back. And I might want to feed that calculator like 100 different sets of data and check that it's coming out the same all the time. Like again, especially when you're handling dates, there's a lot of weird things in dates that can you suddenly find that if it's the last day of February in a leap year, all of your reporting breaks, and you'll never see it again for another 4 years. But that can be quite important to avoid that sort of situation for certain applications. So that's what denormalization gives us, is the ability to do these things. We still maintain our normalized database. We still have that for two reasons. One, because normalized databases are really good at their first stated aim of reducing the redundancy of data and improving the integrity of data. That's really good for our source of truth. And two, they're really good at handling writes. They're optimized for writes. So we might as well use them for writes as well. In fact, we can't really denormalize unless we have a normalized database to begin with. And we certainly can't go from denormalized data to normalized data very easily, when, as we've seen, doing things in the opposite direction is relatively straightforward. But there's sort of something else that this leads into thinking about. It's all this other stuff that denormalization starts to give us, starts to sort of change the way that we think about the database. So denormalization is a projection of your normalized data. Your materialized view is a projection. And if we think back to the start of the presentation, we had Remy's law, which is that your users want Excel. That data that's going into Excel is just another projection of your data. You're projecting your data into this flat format that works for what is essentially one table. I think you should compare this to the third aim of normalization from Edgar Codd, which was that your database should be informative to your users. Your users aren't users of your database. It doesn't really matter to them how the database is structured. And actually, it probably doesn't matter that much to you how the database is structured. I'm a firm believer in the idea that your application itself should represent what you're doing. Your application should be structured in a way that makes it do what it does and makes it do that efficiently. All of the theory around normalization, it does make a lot of sense, but it also comes from a place when sort of the practice of programming was very different to how it is today, and the way people did things was very different to how it is today. If the only way you can ever do things is to have your fully normalized database, you're probably over-privileging your database. You're probably doing sort of data-driven design. You've taken your database, you've decided, I have these things, therefore I need these normalized tables. Therefore, I need these models in Eloquent. Really, be good to think the other way around. My application has to do these things, therefore it needs these models in Eloquent. Here's the resulting database. Your database is a relatively dumb place that just holds on to data for you. I'm sure that there are people here that do a lot more with their database. They use stored procedures. They use a lot of views. That's fine. I come from a place where the application is king. The database, all I want it to do is hold on to things for me. So in a sense, how the database is structured doesn't matter that much to me as long as it doesn't lose any data and it meets my performance needs. So as long as I'm not going to go bang and everything's going to disappear, and I can read and write to it within a tolerable limit, then I'm happy. My application itself is where I really care about how stuff is structured. I really care about what the code looks like. And what we've done, in a sense here, can be applied to a lot of things. So we've done this projection into a different table. What I do in my day job a lot is project into a different database entirely. So I work in MySQL, I work in Postgres, and I work in databases that are very different to those. I work in Google BigQuery, and I work in AWS Redshift. The projection there can go much further, right? I'm in these sort of weird data warehousing databases where I can have a table with 1,000 columns, and the database probably doesn't care that much. So I take advantage of that. Even if you're not doing that, you can take advantage of the same thing. And what we're really doing, in a sense, with this sort of materialized view work, is we're already starting to do CQRS, which is command query responsibility separation. We have a write model, and we have a read model. And it's a really scary idea to have two sets of data and to read from one and to write to the other. But if you have your ORM doing the work for you to keep them consistent in terms of raising these events and triggering these writes to your read model, then actually they're really easy to use and they give you huge gains. So I would say perhaps reconsider how much you privilege your database over your application code. Rather than working for your database, make your database work for you and make it work for your application. Reads are more important than writes for most applications, so let's think in terms of reads. So that's sort of what we do. We normalize the database. Normalization theory, still really good. We identify where normalization isn't working for us, where our reads are slow, where we need to do all this complex business logic, and we just denormalize those bits. Keep using your normalized data for all of the rest. Just denormalize away the pain. And that's it.